Welcome to this course on solution architecting for eIDAS. We'll follow one concrete banking use case, end to end, and use it to explore identity basics, eIDAS concepts, qualified signatures, and how to turn them into a clear, real-world architecture. We'll learn eIDAS solution architecture in 4 steps. First, we build foundations: what digital identity is, how trust works, and the basics of PKI and protocols. Second, we anchor everything in a specific banking use case: remote onboarding and qualified e-signature. Third, we translate that into technical architecture, connecting front ends, identity, signing, and back-end systems. Finally, we look at how to future-proof the design for new regulations and technologies. Designing for eIDAS means aiming at a moving target. Regulation evolves, banks launch new products, competitors appear, and customer expectations keep rising. With a rigid architecture, every change becomes a painful project. With an adaptive one, you can swap trust service providers, add new eID schemes, or tweak user journeys with minimal disruption. Throughout this course, we'll keep asking, how do we stay compliant, competitive, and user-friendly over time? When banks roll out eIDAS-based onboarding, they rarely stay with just one channel. The trick is to keep a single core identity and signing engine and let each channel plug into it. Web, mobile, and even contact center tools all call the same services for authentication, authorization, and qualified signing. That way, security rules, assurance levels, and audit trails stay consistent, while UX teams are free to tailor the experience for each channel over time. In our banking use case, the mobile app is simply another channel plugging into the same eIDAS orchestration layer. Think of that orchestration API as the brain. The app calls it whenever we need a strong, compliant action: onboarding, step-up authentication, or qualified signing. On the device, the app can use biometrics to unlock the session and push notifications to confirm actions, while the orchestration API ensures the overall flow still meets eIDAS requirements. A key design principle here is same backend, different experiences. Whether the customer is onboarding alone in a web or mobile app, or talking to a contact center agent, they should use the same identity proofing APIs and the same evidence storage. That gives you consistent assurance levels, consistent audit trails, and simpler compliance. On top of that, you can tailor UX, scripts, and tooling per channel, without rebuilding the core identity services every time. As you expand across Europe, every country brings its own eID schemes, signature habits, and regulatory nuances. The goal of our architecture is not to hard-code each country into the core banking platform. Instead, we standardize these diverse local practices into a single integration framework at the edge. This framework adapts to local providers while exposing one consistent identity, signing, and evidence interface to the bank's core systems. You can think of the eID integration layer as a universal translator between identity providers and the bank. Each provider speaks its own data dialect for things like name, date of birth, and identifiers. The integration layer normalizes these into one canonical customer model that the rest of your systems understand. That's what keeps your onboarding flow stable when you add, replace, or reconfigure identity-proofing vendors or national eID schemes over time. When you design eIDAS solutions, assume that today's trust service provider might not be tomorrow's. Laws change, pricing changes, vendors get acquired. So you protect yourself by isolating each vendor behind a clear, stable interface. Your banking systems talk to that interface, not to the vendor's quirks. If you later switch from vendor A to vendor B, you mainly adapt the connector, not the whole architecture. That's how you avoid real vendor lock-in. A key architectural pattern here is hiding vendor and protocol complexity behind your own stable APIs. Your business applications only know about one signing API and one identity API. Behind those, you can plug in different QTSPs or identity providers, or even multiple ones in parallel. This gives you flexibility to switch providers, adopt new eIDAS schemes, or add countries without constantly changing every downstream system or user journey. When you integrate a trust service vendor, the big decision is tight coupling versus open, future-proof design. If you rely on proprietary APIs and store evidence in their closed formats, swapping vendors later is painful and expensive. Instead, Push for open standards, SAML or OpenID Connect for authentication, ETSEI compliant signature formats, and exportable evidence packages. By doing that, the bank keeps control of its data and can change providers without redesigning the whole solution. eIDAS 2.0 is shifting identity from centralized logins toward user-controlled wallets. In the traditional model, one or a few identity providers hold most of the power and data, and services simply trust whatever those IDPs assert. With the wallet model, the user becomes the hub. They store credentials on their device, share only what's needed, and can reuse the same trusted identity across many countries and services with less dependency on any single provider. The important idea here is, don't redesign everything just because wallets appear. Treat the EU identity wallet like any other identity source alongside national eIDs, video ID, or smart cards. Your integration and mapping layer acts as the buffer that absorbs differences in formats, assurance levels, and attributes. It normalizes everything into one canonical customer model that downstream systems use. If this layer is well designed, adding a wallet is mainly configuration, not a major re-architecture. As your solution evolves, think in terms of replaceable building blocks. New authentication methods like stronger biometrics should plug in behind a stable identity API. Regulatory changes, for example, new AML rules, should mostly affect policy and configuration, not your core flows. And new trust service capabilities or signature formats should integrate through well-defined adapters. By isolating these three areas, you can adopt future trends without constantly redesigning your eIDAS solution. This is the mental model to keep from the course. Keep your core onboarding and signing logic small, stable, and clearly defined. Around it, use an abstraction layer that speaks standard APIs to the outside world. On the left, identity can evolve. New national eIDs, eIDAS 2.0 wallets, other cross-border sources. On the right, channels can grow. Web, mobile, assisted. The core barely changes. Integrations and channels do.